We've talked about Lua, we've talked about plugins. Now let's talk about modularizing your config. When modularizing a project's files or functions, many people follow different structures. A modular structure in your Neovim config means that you can easily interchange and swap out modules/plugins based on your wish, and you could even automate that if that is your wish. Now here's my Neovim config structure, for example. As you can see, it's pretty modular. Maybe too much, but it's how I like it. Now, I'm not gonna tell you how you should structure your Neovim config. That's totally up to you. But what I'm gonna do is show you how you can modularize your Neovim config, and maybe you can even apply the core ideas to even your other projects. If you wish to keep your Neovim config in a single file and you don't like the philosophy of modularity, you can skip this video and maybe come back to it if you change your mind. Enough yapping, let's get to the good stuff. Now, if you followed the previous videos and or fiddle around with Neovim by yourself, here should be a basic average config. At first, we're probably gonna have a few Vim options set up, then the logic to bootstrap lazy, the plugins and a bit of their configs, and some keybinds. My philosophy of modularizing your Neovim config follows this idea. The init files should only contain global functions that were created by you and only have the require function calling your other module. Now, what exactly is the require function? If we check the docs by doing help require, here's what the doc says. Load the given module. The function starts by looking into the package.loaded table to determine whether mod name is already loaded. Now, what exactly is package.loaded, you may ask? Well, we can just check the docs like how we just did for the require function. A table used by require to control which modules are already loaded. When you require a module mod name and package.loaded mod name is not false, require simply returns the value stored there. Okay, so require checks if the package or module is already loaded or not. Nice. So if it is, then require returns the value stored at package.loaded mod name. Otherwise, it tries to find a loader for that module. To find a loader, first require queries package.preload mod name. If we check the docs for package.preload, it says a table to store loaders for specific modules. See the require function. So when require checks package.loaded mod name's value, if it has a value, this value, which should be a function, is the loader. Otherwise, require searches for a Lua loader using the path stored in package.path. If we check out the docs for package.path, it says that it's the path used by require to search for a Lua loader. It then explains the environment variables that affect it and the template. You don't need to fiddle around with it if you're not doing some weird stuff. Most of the time, your Neovim plugins will just autoload if you're using a plugin manager and or they're in the RTP. So back to the require docs. It does a package.loaded check. If it fails, it tries to search for a Lua loader. If that also fails, it searches for a C loader using the path stored in package.cpath. Another new info we probably don't know about. Well, if we check the docs, we'll see that the package used by require to search for a C loader. Lua initializes the cpath package.cpath in the same way it initializes the Lua path package.path using the environment variable lua.cpath plus another default path defined in luaconf.h. So to sum it up again, package.loaded checks, if not package.path check, if not package.cpath check. If that also fails, it tries an all-in-one loader, see below. And then it explains a bunch of stuff related to modules written in C, which we currently won't go through that much since it's much more complex than this series' scope for the time being. And also, I'm not that good enough in C to comfortably explain stuff about it. Once a loader is found, require calls the loader with a single argument, mod name. If the loader returns any value, require assigns the returned value to package.loaded mod name. If the loader returns no value and has not assigned any value to package.loaded mod name, then require assigns true to this entry. If in any case, require returns the final value of package.loaded mod name. If there is any error loading or running the module, or if it cannot find any loader for the module, then require signals an error. Now that we've gone through the docs, let's explain how you would use this in a day-to-day Lua. This is your file structure. You have an init.lua and a lua-dir in the root dir, and 3 files in that lua-dir called a.lua, b.lua, and c.lua. If you want to load module A, then you would do require A. That's the same for B and C. Now let's do a bit more complex directory structure. Inside of the lua dir, we're gonna have the x, y, and z dir with an init.lua file, and directories called A, B, C. And inside of those directories, we're gonna have the p, q, r file with an init.lua. Now remember that every single one of those files except for the init.lua can have separate names, and for the init.lua file we're going to talk about it later. If you want to require the module x, you can do require x, and the thing is, if x is a directory, which it is in the current structure, you need to have an init.lua in the root of the x dir like we have here. To require the y modules, b modules, r file, you can do require y.b.r. Now here's the modularity structure that I use. In the x modules, a modules in a .lua file, I'll just require the files inside the xa directory. Then I can do the same for the xb and xc, and then just require the a, b, and c module in x modules in a .lua. Now here's a good thing about modularity. For example, Neovim Web Devicon is a dependency for a lot of different plugins that has something in their UI that uses those icons. Now for example, imagine if you wanted to configure the Neovim Web Devicon itself, and if you're using lazy, the recommended way to load dependencies is using the dependencies key in your config table. If you're doing a single file setup, you can make the config table a separate var, and then load the var as dependencies of each plugin that Neovim Web Devicon is a dependency of. Because we're gonna do a file-based modular setup, we can just put Neovim Web Devicon's config in a single file that returns the table, and then just require the file as dependencies of each plugin that Neovim Web Devicon is a dependency of. Now you've learned the basics and philosophy of file-based modularization. Now let's talk about how I would modularize my own config. There should be a separate configs directory which hosts your own config unrelated to plugins and or extra stuff, which could work in a clean Neovim setup. Now you could surely put some plugin related code here if you really have to, but I try to keep that to a minimum as much as I can, make stuff easily debuggable. Now in that directory I have an init.lua which just has my Vim option changes and then requires the other files from that dir. Now for the sake of modularity, I could have made the Vim option change part thing a separate file, but at times if you wish you can just break the modular philosophy. In the end, it depends on how you feel, as you can see from this example. I also have a keybinds directory inside the configs module, and an init.lua file and other files inside of it. Now, in the root lua dir, we also have a plugins dir, which in turn, just for now, should have an init.lua file, and maybe just a few other files. So after I've explained a bit about the dir structure, let's do some configuring. In the end of your init.lua file, we're gonna require the configs module. Then in a different split, we're gonna open lua configs init.lua. Now we're both gonna move our Vim option changes from our init.lua file to lua configs init.lua. Exit Neovim, open it again, boom. No errors, our config still works, and we've reached our first step towards modularization. We're now going to move our basic Neovim keybinds to lua configs keybinds in a .lua and load the keybinds module in lua configs in a .lua. Next, we move the whole plugin setup in lua plugins in a .lua for now and require the plugins module in the root in a .lua. Now my friend, you have a properly modularized config and have a really good understanding of modularization. Videos like this and the fast work I do takes a lot of effort, time and commitment. I hope this was worthwhile to you. If you think that it's worthwhile and okay for you to help me in overcoming my current financial situation, which I have talked about in this video, you can help me by signing up for my Patreon, which is linked to my YouTube bio. You don't really have to do this, by the way. I basically had to force myself in asking for money because I do the stuff I do for the sake of doing it, and I'm still too damn proud to ask for donations. None of my content and or the work that I do for the people will ever be locked behind a paywall while I'm still fucking breathing. If you wanna hang around with me and the community and basically keep up to date with my stuff, you should definitely join our Discord server, which is also linked to my YouTube bio. Thanks for staying this long. I wish you a good life.